Namaskar children. How are you? Okay. Then, what is this? Usually this is used in kitchen. What is the shape of this? Yes, it is a circle. So, now we are going to start a new chapter, that is chapter 10, circles. You have studied in class 9 definition of circles, different terms related to circle, is it? How we can define circles? What is the definition of circle? Circle is a collection of all points in a plane which are at a constant distance from a fixed point, is it? What is the name of the constant distance? The constant distance is known as radius of the circle. What is the name of the fixed point? Fixed point is known as center of the circle. Which are the various terms related to circles? Yes, chord, diameter, sector, segment, etc. Now, we can discuss different situations that can arise when a line and circles are given in a plane. Let us consider a circle and line PQ. There are three different cases. Here I draw three cases, three figures. In first case, line PQ and circle not intersecting. That means the circle and line PQ have no common point. In this case, we can say that PQ is a non-intersecting line with respect to the circle. Okay? Next case, that is, in this case, PQ is intersecting the circle at 2 points, that is, at A and B. The line intersects the circle at 2 points. In this case, line PQ is called secant of the circle. What is secant? So, how we can define secant? Secant is a line which intersects the circle at 2 distinct points. Okay? Third case. What is the third case? In third case, line PQ intersects the circle at only 1 point. That is, only 1 point is common for both circle and the line. In this case, PQ is called tangent of the circle. Tangent of the circle. So, how we can define tangent of a circle? Tangent is a line which intersects the circle at only 1 point. Then the line is known as tangent of a circle. Okay? And this common point is known as point of contact. What is point of contact? The common point for circle and tangent is known as point of contact. In chapter 10, that is circles, we are going to study tangent and its properties. Okay? Then, would you say some daily life situation, daily life example for tangent? Whether you noticed the pulley fitted over a well. The rope on either side of the pulley acts like a tangent. Then, one more example can you say? Your cycle wheel and a road. If road is a straight line and the circle wheel is a circle, then the road acts as a tangent. These are some examples for tangent. Okay, children? What is tangent? Tangent is a line which intersects the circle only 1 point. The common point is known as point of contact. Okay? We have to consider the second case. In the second case, the line PQ intersects the circle at A and B. You have to imagine this A and B coincide each other. That means A and B represent 1 point. Then PQ become a tangent. The A and B coincide each other. That means A and B represent 1 point. Then PQ become tangent. So, we can say that tangent is a special case of secant. Okay. Then last case, at A we draw one tangent. Then we know that passing through 1 point we can draw many lines. So passing through I draw many lines. Okay. What about all this line. Except P, Q, all other lines are secant. Except P, Q, all other lines are secant. So from this we can identify if a point is lying on the circle, there is one and only one tangent. Okay? If the point is lying outside the circle, for example, T is a point lying outside the circle. From T, how many how many tangents? From T, we can draw 2 tangents. If a point is lying outside the circle, then we can draw 2 tangents. Last case, if point is lying inside the circle, if the point T is lying inside the circle, is there any tangent passing through T? No, all the lines become secant. So, if a point lying inside the circle, there is no tangent. If a point lying outside the circle, there is only 2 tangent. If a point lying on the circle, only 1 tangent. Okay? Next, we can study the another property of a tangent. That is theorem 10.1. What is theorem 10.1? The tangent at any point of a circle is perpendicular to the radius through the point of contact. Tangent is perpendicular to the radius through the point of contact. So we have to draw a circle with the center O and xy is a tangent at P. And xy is a tangent at P. That is P is the point of contact. OP is the radius through the point of contact. So what is given? Given a circle with the center O, xy is a tangent at P. Then what we have to prove? We have to prove OP is perpendicular to xy. For proving this, we need one construction. We have to take a point R on xy other than P. We have to take a point R on xy other than P and join OR. Then now we can prove. Here P is a point on the circle. Then R is lying outside the circle. What about the distance OP and OR? Definitely OR is greater than OP because R is lying outside the circle. So OR is greater than OP. If you take any other point on xy except P, all the distances are greater than OP. That means OP is the shortest distance from center O to the tangent xy. We learned in 9th standard the shortest distance is the perpendicular. So we can say that OP is perpendicular to xy. Okay children? So what we studied today? Secant. What is secant? Secant is a line which intersects the circle at 2 distinct points. After that we studied tangent. Tangent. What is tangent? Tangent is a line which intersects the circle only one point. This common point is known as point of contact. Then we studied the properties. Okay? You can prove this theorem. You have to write the proof of this theorem. Try to answer. Okay? Thank you children. With this I am conclude my class. Okay?